I'm not French, so I'm going to try this once. Welcome to Software-Based Networking, Part 2. Hey guys, we're going to do Software-Based Networking Part 2. We had Kyle the first time. This time, we have Mr. Bill Curtis. Bill, how you doing, bud?
Pretty good. How are you doing today?
And you, sir, are a senior PFE out of Charlotte?
Yes, I'm a senior PFE out of Charlotte. I primarily work with network virtualization and the private cloud. One of my customers actually has one of the largest private clouds in the country.
That's really cool. Yeah, I love networking, all things networking inside and out. I've been doing it since the Windows for Workgroups days at Microsoft. And so it's a subject that's near and dear to my heart. So this is interesting.
Yeah, it is, and especially where we're going with software-defined networking is just amazing. All the new capabilities that are coming in 2019 and all the capabilities that already exist in Server 2016.
Yeah.
Just amazing.
Yeah, so I understand you have some cool demos for us.
Yes, I do. Let me go ahead and let's share out the slides. Okay, so what I'd like to demo today is I want to run through some high-level demonstrations on some of the capabilities of Microsoft SDN. Now, these are not going to be the everything that SDN can do, but these are going to be the capabilities that most of our customers are leveraging in their production environments using SDN. So we're going to be discussing micro-segmentation. That is a big ask from our customers with SDN. We're also going to discuss inbound NAT with SDN load balancers. Also, the SDN distributed firewall. We'll do a demo of that, as well as L3 RAS gateways. We'll be covering that, and we'll look at what's in Windows Admin Center SDN. So to kick this off, let's go ahead and demo micro-segmentation. So we're going to talk here about how we can leverage Microsoft Network Virtualization and SDN load balancers to create a simple micro-segmented solution for a web application at a high level. So in this scenario, in this demo, I'm going to show you how we can use Microsoft SDN to create an SDN virtual network, also known as a routing domain, which Kyle Bisnet in his last presentation in Taste of Premier, which I highly recommend that you view first, exposes this solution exposes a Windows Azure Pack installation. As you can see up here on the screen, I have 2 Windows Azure Pack servers. Now, Azure Pack has nothing to do with software-defined networking in this demo. I'm just using Azure Pack as it is readily available and installable distributed web application that is really easy to install. So please don't take the fact that they're Windows Azure Pack servers as part of that solution. So what we're going to do is we're going to utilize the Microsoft SDN load balancers to distribute only port 443 or HTTPS traffic coming in from over the web over a virtual public IP of 40.40.50, which will then be routed through the Microsoft load balancer. Since Windows Azure Pack relies on SQL Server to store its configuration, we will then only expose port 1443 right here through a private virtual IP, same as a public VIP or a VIP, but it would be private, just that network controller knows about. So even if the WAP server is compromised by a black hat, and as you can see this little guy here.
Oh, look at that. That's so cool.
They would only be able to, they could go around and rummage around the WAP server all they want, but they won't be able to get to the SQL Server except for port 1433. That meaning that if they try to do any internal IP scans or anything like that, they're not going to come up with anything. They won't be able to get on the outside network. And that's used commonly in a lot of cloud providers and enterprises. called micro-segmentation, in which case we want to mitigate as much of the threat as possible. And so also in a real-world scenario, you'd want to see, you'll notice that Active Directory has nothing between it here. It doesn't have an internal VIP. It's direct. That's just to keep this demonstration simple. In a real-world scenario, you would also configure private VIPs between Active Directory to further segment the solution. So that's a brief overview right here of what that looks like. Now, in VM, if I go into Virtual Machine Manager, so let's bring up Virtual Machine Manager, and I go and I look at my my VMs here, my Fabric VMs, you can see that I have FabricAM DC deployed. I have FabricAM SQL deployed, WAP1, WAP2. These VMs are just deployed. So in the solution right here, everything's deployed. You just need to know those VMs are there. Now, if I go go into the VMM console here, I have my SDN VM network here. And if I look at my VM subnets inside of here, you'll see I have it segmented out by different subnets. So you'll see that I have a separate virtual subnet for my domain controller, my web front end, the SQL backend that contains the web application, or for the web application. It should be noted that these VMs are in separate VM networks, or can be in separate VM networks if required. And you got to remember that because we're using network controller with VMM, these networks are isolated and they're in their own little sandbox. For any network traffic to get into this VM network, I need to tell Microsoft SDN to either have this VM network connect through a gateway or a load balancer. Other than that, they are perfectly isolated. So we have that right here. And so I have my networks, but now I need to actually connect to them. So I'm going to go ahead and go to my Fabric and go to my VIP templates. Now I've pre-created these VIP templates, otherwise we'd be here for quite some time as I went through each one. But I have one for my SQL backend that's already in play, and then I have one for my WAP front end. And the WAP front end, basically the only thing I want to point out here is that I'm just taking port 443, which is for HTTPS traffic, and I'm mapping it to a backend port. So if you're familiar with working with any kind of load balancers, this is normal. Also, I'd like to point out that we also are able to do TCP probes. So we are able to do health monitors and to make sure your website is up before we route traffic to it through your load balancers. So now comes the tricky part. Now I need to get a little bit into PowerShell here. So I'm going to bring up my ISE right here, and I am going to create my my Windows Azure Pack, or my VIP and my load balancers, using a script that is available online in our documents on how to do this. It's documentation provided on using VMM with network controllers, so it's easily searchable online. All you have to do is on a VMM server with a VMM console is plug this in, fill out these little questions right here, and it will automatically create your load balancer solution. So right here we have FabricAM WAP1 and FabricAM WAP2 VMs, and I'm giving it a public VIP of 40.40.50, and I am going to specify my public VIP logical network pre-created in VMM and give it a name, any name I want to, and I just run it. So after this runs, that's it. Now there's a lot of other stuff in the background, but basically we want to just go. We're basically looking at what we get here. So there's some other things that you have to set up when you do this. Now here I've done some other work that sort of out of scope of what I'm trying to demo here, but I have mapped into the sandbox. I have mapped to fabricom.wap.fabricom.com. I have given in an address of 40.40.40.50 already. So that's mapped. So now we can go in and we can open up Internet Explorer here, and we can refresh here. Okay, so now it finally came up. I didn't put an SSL certificate on here, so it's going to take a second. But we're actually breaking into that sandbox. We are coming in from the outside, and and now we can see that we're logging on to the Windows Azure Pack Management portal right here. So if we go back to our graphic here, you can see that I'm connecting through 40.40.40.50. I'm connecting through port 443 and hitting one of these WAP servers here. Okay, so basically TCP packets bound for the public address on port 443 are routed to the SDN load balancers, which then forward the request to one of the randomly picked SLB muxes, because you're going to have several of them in your solution, and then the request will be forwarded to them, and then the return traffic will be directly returned from the Hyper-V host that VM exists on. So that results in the VM bypassing the load balancer entirely for the return traffic. And this is called direct server return, or DSR. And depending upon your workload, it can provide over 80% performance improvements over a hardware-based load balancer. And again, that depends on the workload. Because usually if you hit a web server, you're making a request to that web server. And that's small. That's going to go through our load balancer VMs. But coming back, usually that's where you're getting a lot of the data. So since we can have as many load balancer, well, we can have up to 8 load balancer VMs, that means that we can scale out very well. And also, it's not really the load balancer VMs. I have to walk that back here a bit. It's the fact is that each Hyper-V host is basically a load balancer itself. So it's going directly up through your top-of-rack switch for most scenarios. And again, it depends on the workload you're using. But for basic information request and traffic coming back, this is going to be way better than a hardware-based load balancer in terms of just load balancing stuff. As for deep packet inspection and other items, then a hardware load balancer might be a better solution for you. So next, let's go ahead and take a look at NAT forwarding. This is something else that the load balancers provide you with. So let's go back to our VM networks here, and let's go back to the properties. And if I go to the connectivity tab right here, we can connect directly to, we can set it to use network address translation. And what I can then do is I can use network address translation to do simple natting to get to, let's say, RDP. RDP is right here. I have it set to go to my domain controller on this network right here, on that subnet. So, and I have it set to use a public IP address of 40.40.40.12. So in this case, I fire up the RDP client, and then I go to 40.40.12, which is conveniently there. And now I can log in without an issue. So now, and I'm in the domain controller. So if you want to think about it, think about if you've used Azure before. If you go to Azure and let's say you look at a VM that you use in Azure, you have a public IP. You also have a private IP. the same thing's happening here. So what you see in Microsoft Azure and Microsoft Azure Stack, which gives you the same kind of experience and nearly the same flexibility, that's SDN on the on-premises servers. It is truly using Azure technology. Yeah. So when I have customers saying, "Oh, it's not proven," I go, "Well, it's pretty proven, considering it's Microsoft Azure." So again, this would be the same thing that you can do for NAT forwarding, and actually the same thing if you went into the load balancer section of Azure, Microsoft Azure networking. And here we have, now we're going to talk about the distributed firewall, and we're just going to do a quick demo, but you can, with Network Controller, you can set in VMM and also without VMM, using Network Controller, you can set firewall rules on, let's say, a virtual NIC on a VM network adapter, as long as the VM network adapter is managed by Network Controller. And also you can set it on a VM network saying, hey, anything that goes into any VM that is attached to this VM network, any VM network adapter that's attached to this VM network, I should say, that is managed by Network Controller, automatically gets these rules. So there's no going in and setting up. One of my customers has to go in and set a firewall for each server and so on. So there's none of that happening. Their firewall rules take 4 days, 5 days to process. And they're probably going to watch this, so you know who you are. And so what you can do here with Network Controller is you can set these rules, you can automate them. Now, it's mainly done through PowerShell, so I'm going to kind of bore you here really with another PowerShell section. So let me go ahead and...
Hey, we love PowerShell.
Yeah. Oh, yeah, we love PowerShell, but it's not, like, exciting, you know?
It's pretty cool.
Oh yeah. So here, so right here, let's go here. Here's our port ACL, and this is using VMM, and I'd like to take a little moment here just to explain that you're seeing me using Microsoft Virtual Machine Manager to demo all of this. I just want to make sure everyone knows that you don't need to use System Center Virtual Machine Manager to use Network Controller. Just wanted to point that out. Now, the PowerShell commands I'm showing you here are going to be a little bit different. If you are using straight Network Controller with Hyper-V, they're going to your script's going to look a little different. But since most people that we've worked with are using VMM at this time for it, we're basically going to use Virtual Machine Manager PowerShell for these demos. So here, in this instance, I want to go in and deny RDP access. In our last demo, I went in and I was able to go in and say, hey, I want to go to that 40.40.12, which is the RDP port for my domain controller. So that demo worked well. So, and you can see it still does work well. I still can get to it. So now, if I go to, I want to stop that. I don't want any RDP traffic, even if I have created a public VIP to get there, or inbound NAT rule to get there. So here, I'm going to go ahead and create a port ACL container in VMM. I'm then going to deny access to anything for port 3389, which is the RDP protocol, so no one can remote desktop into it. So I'm going to go ahead and create that rule, and then I'm going to set that, get the get SCVM subnet web front end, which is not really the subnet that we want. We want to actually go in and get the we want to make sure we get the right subnet. So let's go to properties here and VM subnets and domain controller. So let's go back here and domain controller. And then we can apply this rule right here. So now I should not be able to get into 40, as you can see, I can't get into my domain controller subnet. 4040.12 is just hanging there. I'm not getting there at all. So let's go ahead and cancel this right here and then remove it and just show you that it worked. And I'm using a nuclear scorched earth approach on this script right here because it's getting rid of every ACL because I was lazy. So now we've removed that rule, and you can see how fast and dynamic it is. Now I can get back in, but anything that was applied to that subnet gets that rule right away. And coming with once SDN is available, which should be soon, for Server 2019, there are more features regarding the distributed firewall. Other things that you can do are also user-defined routing and other items that I'm not demoing today. So there's a lot more that we can do here. So that leads us to our next section. So that would be our L3 gateway connections. Okay, so in this demo, we're going to talk about layer 3 gateways. Now, there are 3 different types of gateways that you can use with Microsoft SDN. You can use a IPsec gateway. You can use a generic route encapsulation or GRE gateway. And then you can use layer 3 gateways. So layer 3 gateways basically take your little sandbox that you had of a little sandbox VM network where I said before that you just can't get out of unless you either use a load balancer or you use a gateway. So what happens is we basically are taking a virtualized network and putting it directly, attaching it to a layer 3 VLAN controlled by network controller. So it's a separate physical routable VLAN. We just kind of dump you off on it. And so my customer came to me and said, hey, we need a way to migrate virtual machines to Microsoft Azure. We need a way to migrate our virtual machines off of to Microsoft Azure. And but our VMs are distributed. They talk to each other. So we want to be able to take these VMs to have them in Azure and also talk to them at the same time. So we needed to have a way to talk into Azure. Now we did this with a combination of RAS, a VM inside of Microsoft Azure, and they had an express route. Installation. But some of the stuff to prove out is how we were going to get these VMs talking out of SDN. How are we going to connect up to Azure? So what I have here in a demo is from that, and basically how are we going to communicate through layer 3 with Azure? So in this environment right here that I'm demoing, I have a L3 tenant VM right here. Here's its address, and it's on its own little sandbox. It's a virtualized SDN network, and it's going to communicate with a gateway VM managed by network controller, and it's going to then go out through VLAN 200, which is a VLAN 200 that's in my environment, and it's going to hit a physical router which has a site-to-site VPN connection with an Azure site-to-site gateway. So traffic is basically going out, will go out through this VM, which will need to talk to this Azure VM right here. And if we look at the Azure VM in question, let me go to my virtual machines. You can, and networking. Here is the VM in question right here, 10.1.4 is its private IP right here. And then what we're going to do is we're going to hit the gateway, this gateway VM. VM's going to route out to VLAN 200, go to physical router, and we're going to talk to it. But we need to configure the gateway for an L3 connection. So if I go over into VMM, and in VMM, I go to, you can see that I have a VLAN 200 right here that is managed by Network Controller. So Network Controller needs to manage it. And then you'll see I have that. I go into my VM networks, and I have a tenant VM network, so tenant 1, and it is it basically is just 2 VMs here, most of that, but nothing in connectivity. Now, in Virtual Machine Manager 2016, there is no way to go into connectivity and say, hey, connect to this through a VPN, through L3 connections. Currently, Virtual Machine Manager 2019 will have the ability to actually do this through a GUI. So when you see me break out into PowerShell again, it's not going to be not really difficult, but it's going to be better in better experience in VMM 2019. But you still can get it in VMM 2016. So let's go ahead and get out of here, and then let's go to my tenant VM. So if I'm going to go to my tenant VM right here, and let me log on. And if I ping my address, you remember it was 10.1.1.4, nothing. We're not connected right now. I have to go, in order to initiate the L3 gateway connection, I need to go into Microsoft PowerShell. So back into PowerShell. And this script right here, this nice big script, you can download this much like the VIP script. If you look at the Microsoft documentation on using Virtual Machine Manager and Network Controller and look up L3 gateways, that script will be available to you. So, but to break all the components down, this is what I'm going to use to build it. I'm giving it its VM network name, which is L3. That's the network I want to attach to the VLAN. I'm giving it the next hop VM network name, which is VLAN 200. And then I'm giving it a local IP address. And if someone actually goes in and looks here, like a local IP address, what's that? Well, that's basically the name of the gateway that the endpoint and entry point IP on that VLAN where you're going to talk out of. That's where you need to configure maybe your static routing or BGP routing or what have you to use this IP address in order to get to the addresses that are inside of that virtual network you're connecting to. And then they have pure IP address, which is basically the default gateway for the VLAN VLAN 200 here, just its default gateway, which is usually .1. And then gateway subnet, which really can be any address. Just make sure it's not used in your environment. And then I'm able to do routing subnets. And right here, I'm telling it to go to 10.0.0/8, which is it's 10.1.1.4. I'm telling the gateway to only service requests from that virtualized VM, only service requests going to that subnet. Or subnet. So the gateway is going to ignore all other requests because, well, you want everything to be blocked. So I'm going to ask for that. I'm going to kick this off because it takes a little bit to run, a little time to run. But interesting about routing subnets is that you could actually put 0.0.0.0/0 and basically broadcast address and it will allow all traffic to go out the gateway. But here, if you put the routing subnets, you can really drill down and get it just right. Another thing is that you can enable BGP, just like you can on your networks in Azure. So you can have this L3 connection peer with another BGP server using the gateway. Each gateway VM has its own BGP server, so it's able to peer with other servers for routing information, and sort of so you don't have to really worry about the routing subnets section. So this is going to go through, and boom, we have created the gateway. Now let's head back to my VM here, and as you can see, that L3 connection was created.
Woohoo!
Yes, so demo gods are smiling today. Now, the next part is what happens if the gateway fails? So, and I always like blowing things up. So let's go ahead and take a look at our gateway status right here, and let's blow something up. So I'm going to go to gateway status, and this is a PowerShell script that I wrote right here. It just queries network controller because it's a REST API and it's that PowerShell module. So I just run it right here, and it will tell me where my gateway is. So right now I'm on gateway 3. It's active, and the IP, and you can see that it's on gateway 3 VM is the one using it. And then this is my L3 gateway right here. So with gateways, when you deploy them, you're going to want, because we work on an M+N model, you always want to have a redundant gateways. You want to have a set number of gateways to take over if something fails. So right now I can see, I have gateway 3 here. So if I have gateway 3, then I can go, and gateway 1 should take over if something bad happened to gateway 3. So let's go to my VMs right here, and that's VM networks. That's not my VMs. And again, back here, because I have the memory of a goldfish today, and gateway 3. So gateway 3 needs to be shut down. So let's see how long it takes for the failover to actually occur. So we're back, and let's head back to PowerShell. Let's run this. Okay, well, that was fast. What if we go into back into the VM here? Boom. That was pretty quick.
So it was down for one ICMP echo.
Pretty much, and believe it or not, it's faster in 2019. This is VMM 2016. So it came right up. So if you need to do maintenance and so on, it all comes down to planning. So so really, the gateways are really resilient, and there have been substantial improvements on the IPsec and GRE gateways as well in Server 2019 that needs to be looked at. So
this is a pretty geeky question, but if I'm sitting on a client in a subnet and I need to find a default gateway, I'll if I don't already have it in my ARP cache, I'll just ARP for whatever the IP address is for my default gateway, and it'll return its MAC address, and I'll know how to get to it. What happened here? Does the client have one MAC address that it gets mapped to all 3 of these gateways, and then the gateways switch on the back end? Or do we actually have 3 physically separate gateways set up on the subnet?
Just one gateway.
One MAC address as far as the client is concerned.
As far as the client's concerned, it doesn't know it's in this environment. So
right, which is why it was so fast. Because if it was the other way, right? So let's say we were relying on the ICMP message that comes back and says, "Hey, the gateway's down. Go try a different gateway." We'd have to then figure out where we want to go next and ARP for whatever that is, populate our ARP cache, and move along. That's why it can be faster. It's because it's all just one MAC address as far as the client is concerned.
Correct. It's one MAC address because basically all communication on for these VMs that are on a HNV network are they're oblivious to it. It's all handled inside of the Hyper-V switch.
That's so cool. I love that.
Yeah, and network controllers in there, and that has all the rule sets inside that Hyper-V switch. So you get into things like provide. So basically, if you like, let's say if I want to route a packet to this VM right here, from another VM. What happens is that this VM will say, hey, I want to talk to this VM, or I want to talk to this outside VM. The VM switch on the Hyper-V host will take that packet and put it into another packet. It's called encapsulation, and ship it, but it has a table, like a DNS lookup table, of where that VM's MAC address is and what Hyper-V host it's running on. And so it puts it in a larger packet addressed to that Hyper-V host, and that VM switch figures it out when it gets to that target IP host, and rinse and repeat for all traffic IP flow.
Yeah, that's cool.
Okay, so earlier in this presentation, I mentioned that, hey, you can use network controller without integrating it with Virtual Machine Manager, or having a network controller managed from Virtual Machine Manager. And so I wanted to show you a little bit about that here. In 2016, you were able to do that by using SDN Express to install it, or so on, but you weren't able to use VMM to manage network controller. You had to do it all through PowerShell, which for our cloud service providers is not a big deal. We love PowerShell. They live in PowerShell. DevOps people live and breathe in Python or PowerShell. And so here we have a network controller that can be managed by Windows Admin Center. One thing to notice here, though, one thing to note, I should say, and also notice, is that it needs to be a Hyper-V converged cluster. So to use Windows Admin Center to manage network controller. And you don't have all the features. You can't create new gateways currently. You cannot set up load balancing. That still has to be done through PowerShell. However, you're able to use virtual networks, create virtual networks. So you're able to do that. So in this installation right here, which in Admin Center is usually really, really fast. It's just this is in a nested VM environment. So you're actually able to create virtual networks in Network Controller using Windows Admin Center, as well as monitor the health of your environment. So I'm able to go into SDN monitoring and load up and see the health of my environment. If the other way to monitor SDN health and how it's doing is to use the SDN Management Pack plugin for System Center Operations Manager. So so you can look at this here. Now, one thing to note here is that this is constantly evolving. So you are there are more new features that are being worked on to be added to Windows Admin Center, and at some point you're going to be able to pretty much do all the management for network controller and so on from Windows Admin Center in the near future.